CCE is a process, is a methodology, but I think the core of it that we're trying to get at is we're trying to actually change how people think about cybersecurity.
Hey everyone, this is the Industrial Security Podcast, and my name is Nate Nelson. I'm here with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions. He is going to introduce the subject and the guest of today's show. Andrew, how are you?
I'm very well, thank you, Nate. Our guest today is Sarah Freeman. She is an industrial control systems cybersecurity analyst at Idaho National Labs, and she is the co-author of Countering Cyber Sabotage, Introducing Consequence-Driven Cyber-Informed Engineering. And the topic is her new book and the CCE methodology.
Then without further ado, here's you and Sarah.
Hello, Sarah, and thank you for joining us on the podcast. I know that we had your colleague Andrew Bachman on, your co-author, talking about what was coming in the CCE book. This was a year ago, and I'm delighted to have you on now to sort of show the other side of the coin. Now that the book is out, let's talk about what you actually produced in the book. Before we start, though, can you give us a little background about yourself? And, you're at Idaho National Labs, a little bit about the labs as well.
Sure, and thank you so much for having me. I am an industrial control systems cybersecurity analyst at the laboratory, where I've worked for the last 8 years. Before that, I worked in actually a lot of financial services, cybersecurity, and threat intelligence. So I have more than 10 years, approaching 12 years experience in this field, which is a little bit of a nuanced area. That being said, highly applicable to the book, Consequence-Driven Cyber-Informed Engineering, and very important to the general process. The book, as you mentioned, has been a long time coming. It's really been a collaborative effort. I think that's part of the reason why it took us so long to get through it. So there's a lot of, it's something we've been working on for a very, very long time, probably close to 5 years. And even in the early days, just the number of people that invested their time in it is really quite substantial. But it does line very well with the general strategy and vision of Idaho National Laboratory, which does have a major focus on securing industrial control systems and critical infrastructure collectively. And so in some ways, CCE is part of a broader portfolio of programs and projects that aim to do just that, in part through research, industry engagement, and general increasing situational awareness for people in the field.
If I remember correctly, we've had on already multiple guests from Idaho National Labs. Andrew, how big is their operation over there? Is it just luck, or do they just have a lot of people?
No, it's a very big operation. I mean, these folks run their own experimental nuclear generator. They run their own power grid. They do a lot of electric system research. They run, what used to be called, I forget what it's called now, but it used to be called the Industrial Control System Cyber Emergency Response Team, the ICS CERT 4, under contract to the Department of Homeland Security. They do security assessments on industrial sites for the Department of Homeland Security, and others who are requesting it. They have the flyaway teams when there's an industrial incident. They pack up their equipment, they get on the planes, they go and investigate the equipment. I don't know what the number is, but it feels like at least a couple of hundred PhDs. It's a very big operation. So the book has been available on Amazon, at least in electronic form, for a couple of weeks. I know when I discovered it there, I immediately downloaded it and then tried to get through it. It is a few hours read. It's some of it is a little bit heavier going. Can you summarize it for us? What this is. This is for the record. It's consequence-driven, cyber-informed engineering. Okay, not security, but engineering. Can you talk about the methodology? What is sort of the big picture of what you're describing in the book?
Sure. The book, which does primarily focus on trying to articulate the process of CCE, is very much engineering focused, as you can gather from the title. It is different than normal cybersecurity procedures and general risk mitigation strategies in the sense that it really does focus heavily on bringing engineers to the table. That said, it's designed to be a holistic approach, almost multidisciplinary in terms of the parties that are involved. But one of the things we've seen at the lab and, just in critical infrastructure protection in the industry writ large is that there's a tendency to overlook some basic differences between industrial control systems, operational technology, and the IT brethren. So those differences are highlighted in the process, and the book itself is trying to provide not only a backdrop for how the process came to be, but general guidance and information about the origin and philosophy. CCE is a process, is a methodology, but I think the core of it that we're trying to get at is we're trying to actually change how people think about cybersecurity for these systems. And in order to do that, we really have to educate on more than just follow these steps and these orders. That being said, we do provide plenty of steps. There's also an appendix that goes through a hypothetical process with a hypothetical country, and there are some checklists at the back. So there's a lot of material there for anybody who would be interested in trying to dig a little deeper.
Can you talk a little more about the engineering focus? How is the engineering focus different from a classic enterprise security focus?
When we talk about industrial control systems cybersecurity, we really have to take into consideration why these systems were created. In a lot of ways, they're designed to ensure there's certain reliability and cyber physical processes. So everything gets tied to some degree back to that thought. So if you're looking at threat intelligence, for example, for industrial control systems, you always have to stop and say, okay, what could be the potential physical impact of exploitation of the system, which is very different than on the IT side, because the consequences of some of these cyber attacks can be quite devastating. That is at the core of its issue. At the same time, Idaho National Laboratory, with a lot of their work, this is something they've been doing for a long time, because their history is actually in nuclear control system design and reactor design. So if you start from that perspective, you see a lot of, commonalities in terms of the evolution of the thought process. There's requirements that we need in terms of making sure that our industrial control systems run safely and securely, and reliably. And that's kind of, I think, the meat of the issue. There's also general practices that don't necessarily align with IT strategies when it comes to security that are a little interesting. Things like, as we've increased connectivity on the IT side, we've also increased visibility and our ability to monitor in a lot of ways. That there's still a lot of debate on the OT side about whether or not that is an approach that should be adopted. That being said, obviously, technology moves forward at its own drumbeat, and so there are certain things that the industry on the OT side is really starting to grapple with. How can you digitize? How can you increase connectivity and ensure that these systems remain secure?
What you've said makes a lot of sense. The engineering profession, most engineers are yes, first focused on safety. You're building a bridge, make sure it doesn't collapse. And second, focused on reliability. How long is a bridge supposed to endure? Keep the lights on. I've got, keep natural gas in the system. I've got minus 26 out there behind me and out the window. I really want my natural gas to be reliable and my lights to be on. But what I've seen really is that driving connectivity is not so much visibility as efficiencies. Visibility enables efficiencies. And the tension is not between safety and security and connectivity. The tension is in my experience, between connectivity that enables efficiencies and then the cyber threats that come back to safe and reliable operations. Is that fair? Is that really what's going on here?
Yes, actually, I would agree with everything you've said. When I speak about increasing visibility, I'm biased in my viewpoint, in part because that is a large focus of an area of concern for threat intelligence. So there's things that we push onto systems because we think if we can see them better, if we can understand the mechanics of how data is shared or how data is used, that we can somehow create an understanding of what normal is and then use that for anomaly detection. From an engineering perspective, everything that you're saying is spot on. There's a ton of efficiency that's gained, and that has been, if you just look at things like the energy sector as an example, that has been the incentive for a lot of this innovation.
You mentioned earlier in your introduction also that there is a methodology. There are steps in the methodology. Can you summarize the methodology for us?
The methodology is broken into 4 steps. Honestly, it used to be more than 4, but we made a decision that 4 was probably the best way to present it in a way that was kind of consumable without spending a lot of time memorizing each one of the individual steps. But there are 4 steps, the first of which looks at prioritizing based on potential impact of cyber attacks. That's consequence prioritization. The titles are fairly self-explanatory once you get familiarized with the process. The thought there is that rather than try and boil the whole ocean, if you can focus a little bit, then you can develop better mitigation strategies and ultimately take a little bit of the pressure off from doing the remaining parts of the process. In a lot of cases, when you're looking at doing some of the more common assessment or widely adopted assessments right now in cybersecurity, they're really onerous processes. Some of these assessments can take years, and they're a full-time job. And after you finish one system, you go into the next one. That is not what we're trying to do here for so many reasons. One of which is we've seen adversary growth move so quickly that in order to have any chance at all of keeping pace with what that side is doing, we really need to hone in and focus on those things that are most damaging. That fits very well with critical infrastructure, as the name suggests. Being critical, there are certain things that can be really, truly devastating if we're talking about cyber attacks. The second phase, systems and systems analysis, is looking at trying to understand what information exists on your systems, who has access to it, what data is necessary for an adversary to conduct an attack, and ultimately recognizing, as you mentioned previously, that some worst case scenarios, when you start to peel back the layers, are actually not possible via cyber attack. That might mean that they might be possible via some other means. For example, normal kinetic attack, or if somebody had physical access to your systems. But we're trying to really hone in on some of these cyber specific events. The third one focuses more on laying out the specific steps an adversary will take to target your systems. This is interesting because there's actually been a lot of research in this area, understanding how attack paths work, understanding what your attack surface is, looking at attack trees. There's a lot of mechanics out there for that. CCE is different in the third phase, consequence-based targeting, because it starts not from how an adversary will get onto your system, but how they will intend to have their final effect. When we look at industrial control system cybersecurity, we often talk about attacks in 2 stages. There's a lot of work and some really great papers on that topic by Sands, if anyone is interested in reading them. If you look at the second phase, stage 2 of these attacks, that's where we start the conversation. So rather than do kind of more of a traditional attack tree where you say, how would an adversary breach my system and what would they do next? We say, okay, there's hundreds, perhaps thousands of ways an adversary can get onto your systems, but that's not the most important thing. If we put all of our effort into trying to mitigate every single way that somebody gets onto your systems, you'll probably use up all of your money, time, and resources, and frankly, energy to try and address this issue. But if you can take a step back and say, okay, what would be the adversary goal on target? And how can I best disrupt the adversary, the attacker's processes, so that they have to change what they're doing, or they have to pick a less substantial target, or they have to go look at a different victim? All of that is the primary focus of 3. And so phase 3 is it's an interesting phase in that a lot of people struggle with it because we've laid the groundwork for so long, in conversations about spear phishing and setting good passwords and making sure that your password security is valid. There's this fixation in the industry a little bit on approaching it from the other end. And so it's a little bit disruptive to people to be like, no, I don't care how they got there. I care what they're going to do. The fourth phase, protections and mitigations, is all about taking everything you've learned through the process, really disentangling all of that data to some extent, bringing in people who may not have been part of the process but might have really great ideas moving forward, and then honing in on the best options to stop those worst case scenarios based on the technical targets identified in phase 2 and articulated in phase 3. A lot of people ask questions at that point because for some, they say, well, if I know the worst case scenarios, if I kind of understand what these high consequence events are in phase 1, then why do I need to do 2 and 3? It sounds like a lot of work. And it is a lot of work, but the problem or the benefit, depending on your perspective, of going through that process is that the solutions that you create in phase 4 are highly specific to your own application and your own systems. These are not generalized advice about how to secure assets. We're really looking at specific implementations and trying to apply the best solution for your case.
Waterfall Security Solutions is the OT security company. In our latest report, we look back at 2020. We observed that the most important threats in 2020 were targeted ransomware, supply chain breaches, and cloud connectivity. We pull these threats together into 4 new kinds of blended attacks. Then we look at different kinds of cyber defenses, and we determine how effective these defenses are against each of these modern attacks. To access these insights into today's threats and what can be done about them, please download our report at waterfall-security.com/2020report.
I found Sarah's response there surprising in one sense. She said that the CCE methodology was designed specifically to be, in a sense, faster and more efficient than other methodologies that are full-time jobs that take years, and by the time you're done the analysis, the threat environment has changed so much. You got to question if the analysis is still valid. That was a surprise to me because I was used to sort of more cursory risk assessment methodologies that a lot of assessors will go in there, they'll run some tools, they'll figure out how many patches you're missing, and in 3 weeks have a report and they're out. And I had thought that one of the claims to fame for the CCE methodology was that it was much more thorough, especially in the system of systems analysis portion. But I guess they found a middle ground between the paralysis of analysis for years long risk assessments, versus the very cursory stuff that I was thinking you need to do something more thorough.
I would say for myself, if there was anything that stood out most from her answer, it was the third phase of her methodology. As she noted, in industrial security, we usually focus so much on prevention because we're dealing with very sensitive and dangerous machinery. The way that she described her methodology, it sounded a bit more like the way I imagine ITsec people approaching their systems, where instead of working so hard to prevent an intrusion, you anticipate, you expect the intrusion, and then you focus on dealing with it, which seems unique relative to what we usually talk about.
It is, but it's not as different from what we usually talk about as you might expect. In the IT space, let me back up. Let's use the terminology of the NIST framework. In the NIST framework, there's 5 large areas of any kind of security program. There's the identify area, which has to do with planning and responsibilities and procedures. Identify, protect, detect, respond, and recover. The IT philosophy that you're talking about there, a lot of IT folks will yes, assume they have been breached and focus on detection, focus on systematically, looking at, analyzing, discovering the breach so that you can respond and recover to the breach. CCE assumes a breach, but their next step is not to set about detecting the breach. Their step is assume the breach in your mind so that you can apply the system of systems analysis, you can look at the remaining steps, the next steps an adversary has to take in order to bring about a consequence, so that you can design your systems so that the adversary has a very, very hard time taking those next steps. So you assume the initial breach, but the focus is still protection, not the classic IT focus on detection. The focus is on assume the breach, but design the system to prevent the consequence in spite of the breach.
I think I mostly understand what you're saying, but there's still the matter of if we imagine an attack in stages, usually when I think about prevention, I think about the initial stage. So the point at which the attackers cross the threshold of getting into your systems. In this case, it seems to me, based on what you're saying, that we're not actually talking about that. We're talking about prevention at a lower level, at a later stage. What implications does this kind of thinking have?
I think you've hit the nail on the head, which is, a lot of IT folks have recognized the difficulty of, preventing any kind of compromise on an enterprise network, because the enterprise network is exposed to the internet. We're pulling email, we're pulling web pages, we're pulling who knows what kind of nasty into the enterprise network all the time. And so this is why, in my understanding, there's such a focus on detection in the enterprise space, because you have to assume that, sooner or later you're going to be compromised. You'd better be, trying to find that compromise. But in the buzzword in Sarah hasn't used the buzzword, but the buzzword in a lot of industrial security is defense in depth, layers of defense, and you assume that the outermost layers of your defense are most likely to be breached because they're the ones exposed to constant attack. And so what Sarah has said is, like IT, yes, assume that you've been breached. But, it's the IT folks' job to protect the enterprise network. It's CCE's job to protect the industrial network, which is deeper into the defensive posture. So yes, assume that the enterprise network has been breached. Assume that the enterprise people are dealing with the breach. And design the lower levels of defenses so that turning an initial stage breach on the enterprise network into a material and unacceptable physical consequence. Design your intermediate layers of defenses so that the process of turning the first step into the last step is, as close as you can make it, practically impossible. So you mentioned, stage 2 of what I assume is the ICS cyber kill chain. Can you remind us what is stage 2? Where are you starting?
So the first phase of the SANS kill chain process, stage 1 attack, is where you'll see a lot of the initial activity, perhaps on target, but even things before an adversary gains access to your systems. Things like open source reconnaissance, the spear phishing campaigns. Then once they have access, they found a weak link in the system. They've targeted someone effectively. Then enumerating the network, building out their understanding of who the systems, the users are, and then kind of maneuvering through it in order to access the operational technology or any segmented networks if there are any. So the second stage of the attack is more about what the end goals of the adversary would be. So there's specific actions that would be taken if you're looking for physical damage. There's other actions that might be taken if somebody just wanted to have a disruptive impact to operations, such as loss of view or loss of data. So that's where you'll see things where either denial of service on select targets and or wiping specific resources, which can be really damaging to some extent, but not as bad as physical damage to a plant or a process.
I'm still a little confused. Is stage 2 a set of activities, or is it, in a sense, a foothold on an IT network or on an industrial network?
Stage 2, at least in the breakdown that they've laid out, is a set of activities. It's after an adversary has figured out what they want to do with the system and they move to that final attack process. We tend to lump attacks as one event. Somebody shows up on your system, and in some amount of time, 24 hours or later, they've attacked a specific component or wiped a system. But a lot of times, especially with industrial control systems based or operational technology based attacks, you're talking about a lot of preparatory work. And so when you look at the threat intelligence and the data that we do have about how these play out, it's very common for attackers to be on target on the victim's network for months. All of that first part is them learning your system and learning how to hurt you. The second stage is where they maneuver into that final attack phase.
That is something that struck me when I read the book. It seems very focused on the kill chain, and the kill chain, in my terminology, is a targeted attack. Somebody wants to bring about some undesirable end, and is deliberately targeting somebody, working their way deeper and deeper into a particular system. Is there no concern in the methodology about sort of more commonplace attacks like I don't know, malicious insiders, or common ransomware coming in on a USB and taking over all the Windows machines without any sort of deep understanding of how the control system works? But if you cripple 25 Windows machines, you've probably crippled the control system. Is there no place in the methodology for that sort of commonplace stuff?
There is still interest in mitigating those types of common attacks, as you call them. The interesting thing about the CCE process is if you start with the worst cases, you often end up mitigating some of those more, a lot of people call them non-targeted attacks. I think that it's challenging to explain the benefit without having gone through it, because this is something we've struggled with throughout the entire process of trying to explain this with people. People usually get it. Organizations often get it after they've gone through a CCE engagement, but it's difficult to change people's focus and say, it's not that we're not worried about ransomware. We are worried about ransomware, but this is a very special set of criteria and scenarios that we're looking at. So CCE was designed to try and address a gap that we saw, and we felt that there was a lot of effort and a lot of organizations that were focusing on trying to increase the resiliency of systems to attacks like ransomware or insider threat. So recognizing that gap and then trying to mitigate the weaknesses we were seeing in our protection strategies, we really wanted to hone in on some of these worst case events. If you talk to anybody about CCE, they'll tell you that it's not that we don't think cyber hygiene, as it's often referred to, is important. We do, but this is something else. So we don't want you to stop doing cyber hygiene in favor of CCE, but maybe if you have progressed in your maturity and you feel like you've nailed the best practices that we have today in terms of cyber hygiene, maybe this is the next step.
So you mentioned in your introduction that the methodology is intended to be sort of simpler and not as long, not as time consuming as some competing, very lengthy methodologies, because the threat environment is evolving so quickly. So my question is, how often do you do one of these assessments?
CCE is designed in some ways to be a continuous process. We designed it with the idea that it would be iterative. So in many ways, once you have adopted the mindset, you can just continue to feed one of these assessments into the next.
A couple of episodes ago, we had a guest on talking, gave an analogy, cybersecurity analogy, said, look, think about breaking into a building. There's really only three ways into a building. You can come in through the roof. You can come in from underground, the sewer system or whatnot, or you can come in through a wall. Is there a similar, an analogous set of unifying principles to CCE that you can point out?
Yes. CCE is fixated, especially in phase 3, on the concept of attacker requirements. So even though you might be considering multiple outcomes of an attack, multiple motivations, there's often only a few technical targets that will meet those requirements. And so there are natural bottlenecks that appear as part of the process. Much like the building where there's only a few entrances, there's only a few places in the system where these devastating effects can occur. And so once you've identified those, you can focus all your efforts tightly on mitigating and increasing the protections at that location.
So something you've only touched on in passing, but I think if I recall right, gets treatment in at least a chapter or two in the book is sort of non-cyber mitigations. Can you talk about that? How does that fit into the overall strategy here?
Those are, in some ways, the silver bullets when we talk about the fourth phase that we're really aiming to identify. If you consider these attacks, there's physics of the attack themselves that are what we're trying to mitigate and eliminate. And so if you're able to come up with a physical fail-safe, then it is possible that you've ultimately taken the cyber option off the table for the adversary. There is no way that those devices can become hacked. In many cases, that's not always possible, so we have to also apply other options. One way to think of it is if you look at the NIST 5 functions, and we start with identify in that case when we're doing phase 2, but the mitigations and protections we look at: protect, detect, respond, recover. We want to prioritize protection-based activity first. And if full protection is not possible, then we start looking at detection, response, and recovery.
Can we talk about scope for a second? A lot of the examples in the book are process industries, power sector, pipelines, I imagine, are in scope. You even mentioned, I think military installations, high security, high consequence installations. How about manufacturing? I mean, let's say we have an automobile manufacturer. In my dim understanding of that space, a lot of what happens on the production line is done by robots. Robots are intrinsically cyber. There, to my knowledge, isn't a lot of physical mitigation that's possible there. Is discrete manufacturing in scope? Can you talk about the scope of the methodology here?
Yes. I think that the scope of the process we really had envisioned for all operational technology or cyber physical systems. That said, especially when you read the book, you do get almost the INL bias, which is we do have certain industries that we have more experience trying to mitigate potential cyber risk. At the same time, manufacturing has a lot of the technologies that could be at risk from a whole series of events. So there are still physical type options that can be put in, and by that I mean there may not be a vibration sensor like you might have if you're looking at a turbine genset, but at the same time you might be able to put something in place that's not hackable. A discrete point, for example, that a monitor's temperature might be set up to a separate alarm system. It's very complex for the attacker to manipulate that point because it's not necessarily connected to the rest of the system. So depending on what the process is or what the item is that is being manufactured, there's other checks that can be put in that try and limit the damage that can come from losing a whole batch of manufacturing to a cyber attack.
So usually we're commenting on what the guest says, but in this case, Andrew, you actually asked a question that I could use some clarification on. Specifically, you mentioned that say the robotics involved at an automobile manufacturer are intrinsically cyber, and for that reason, it's difficult to sort of mitigate the physical security component. Could you explain just the logic there and why this aspect of industry in particular would be prohibitive?
The book, and if you remember, Andrew Bachman was talking about physical mitigations. I mean, we've had the folks from Connexus on as well talking about the security PHA review. The physical, classic physical mitigation is an overpressure valve. If you have a boiler and you don't want it to blow up when there's too much heat or too much, an exit is blocked. You put an overpressure valve. It's a mechanical device. When there's too much pressure, it's physically forced open, and the pressure is released. The steam is released, and you don't have an explosion. Or you might put a clutch on a turbine, so that if the force on the turbine is so large that the turbine's going to deform and break, the clutch instead breaks, and you save the turbine. These are physical mitigations. And, these physical mitigations, the examples that I heard in the security PHA review, they all really applied to process industries. Process industries are where what you're manufacturing is more or less continuous. Everything from mining to pipelines to power to oil and gas refineries. It's continuous. Whereas something like automobile manufacturing, washing machine manufacturing, computer manufacturing, you're taking small pieces and building them up into bigger pieces. It's called discrete manufacturing. And a lot of that manufacturing involves robots. I mean, imagine, the pictures you've seen of automobile production lines. Big robots picking up, the engine and dropping it into the automobile. And the thing is that I have a hard time imagining physical mitigations for automobile manufacturing. I mean, an overpressure valve is not hackable. It has no CPU in it. It does not matter how clever the adversary is. They cannot do something to a computer or a program or some data to impair the operation of that safety check that prevents disaster. But the robots are intrinsically computerized. You cannot operate a robot without the computer. The robot is, in a sense, the computer. And so my question was, when you have these intrinsically computerized operations, does CCE still make sense? Because it's hard to imagine a physical mitigation that would save a robot from, hurting itself or something. But Sarah's answer was that discrete manufacturing is in scope for the methodology. And yes, there are physical mitigations that are possible, but some of them are still, computers are still involved. You might have a vibration sensor on the robot or a stress sensor on the robot if the stress is too great. But that sensor, what I heard Sarah say, she echoed what I heard people like Joe Weiss say. She echoed, some stuff that I've heard in other people talking about. Look, if you've got a computerized sensor that's that important, don't connect it to the network. Put it on its own little space. Let it do its thing. If it senses that the stress on the robot is so great it's going to break something, then it can trip the power to the robot so that the robot doesn't hurt itself. But, that's a cyber mitigation. But if you want it to be, in a sense, unhackable, it has to be, hidden away in a place where the adversary cannot get to the computer that's part of that cyber mitigation. So that's a subtlety that, I hadn't picked up that's a possibility I wasn't aware of in the discrete manufacturing space. You mentioned a focus on protection versus detect, respond, and recover in the NIST framework. You are focused on engineering. I think the engineers get this. How does this go over with the enterprise security practitioners that you're inevitably also interacting with?
That is a very good question, because in many cases, not well. And initially, I think that in a lot of ways, the process is in direct conflict to some of what they think they're already doing. But it's really important that they recognize that this is a process that requires their involvement. They are experts in their field, and so we need their consideration as well. But when you look at the mitigations, one of the things you see is if you can't put those protections in place, those engineering designs and controls in, then the next parties are all of those organizations that are probably more on the communications and technology infrastructure itself. So whether that's the IT or the OT staff who are responsible for securing those networks, you need their participation and cooperation for some of those other options. And depending on what the technology is, they may be lead because honestly, there might not be a physical control that's possible. One of the examples I like to refer to a lot is actually distribution management systems in the energy infrastructure, which often have, for example, smart meters that are now everywhere to monitor power usage of individuals or businesses, industries. Those are highly digitized systems. There's very few physical controls that we can put in there that would eliminate the risk entirely. So at that point, you're really talking about a mitigation, and the options that you are putting in for those kinds of things, some of them are procedural, some of them are operational. How many updates should you push at once in case there was a problem with the update and has been maliciously altered? Or maybe there's a way that you can redesign the infrastructure so that you can segment sections of the AMI, the advanced metering infrastructure, if there was a problem there. But again, all of these start to look at response recovery options. And then on the detection side, if you can quickly identify an adversary on target, if you can recognize when malicious activity is going on, then what are your next steps?
Can you talk about residual risk? I mean, you've said let's look at high consequence events, but a truism of cybersecurity is that given enough time, money, and talent, an adversary can defeat any set of mitigations that we've put in place. There's always risk left over. Can you talk about how we identify that, how we manage that?
I think that there's a couple of things that are important to keep in mind. The first is part of what we're trying to do here is increase the cost to the adversary to perform these actions. So while it is possible that you might not be able to fully mitigate the risk, sometimes attacks become less attractive because the amount of adversary investment that has to occur in order to be successful. The other part, which is very complex, and it's one of the reasons why CCE is designed to be a process that's walked with an organization and their own internal experts, is that it's really not INL or frankly any organization's outside organization's position or prerogative to explain to another what their risk posture should be. What we're trying to do here is educate so that people can have a better understanding of what their cyber risk is, and then that information can be integrated into normal business making decisions. There's a lot of infrastructure and individuals inside the organization who can more clearly articulate what their company is most concerned about.
Sarah gave a very short answer. Let me say just a little bit more. There's always residual risk. This is classic risk management. There's no way to eliminate all risk. And so it's the business decision maker's job to decide which risks to accept. So that's classic risk management theory. But I think the point that Sarah made about education here is vital because the threat environment continues to get nastier. The tools in the hands of our adversaries continue to get more powerful. And there are constraints on how much risk certain kinds of businesses can accept. Critical infrastructure providers are expected to provide the important services to society more or less continuously. Safety risks. There are societal expectations around how safe certain processes have to be. And so the education here is vital in terms of informing business decision makers about how exposed they are to certain consequences that they've already decided are unacceptable, but they may not have realized that there's this an unacceptable degree of exposure to these consequences. This is I think this education function is a vital aspect of any kind of risk assessment, and I'm happy to see that it's emphasized here. Something else that struck me when I read the book was, in hindsight, a surprising emphasis on supply chain security. I mean, this book was written long before the bulk of it, I imagine, was cast in stone long before the SolarWinds Orion breach. Can you talk about supply chain and how it sort of it's almost prescient what the book is saying? Can you talk about how that came to be?
Supply chain security is a huge issue. it's almost impossible to guarantee that your systems are secure if you can't guarantee a secure supply chain. But there are certain things you can do, which is one of the key points we were trying to get across. I don't know if you're familiar with Richard Danzig's piece, Surviving on a Diet of Poisoned Fruit, but one of the core tenets in it is this concept that you can't guarantee that your system will be secure. You can't even guarantee it will be secure upon arrival after you've procured it. But how perhaps we can take a step back and consider engineering principles that mean it will still function as intended because we've put safe gaps in there that eliminate the effectiveness of a supply chain attack. If you know your hardware or your software is already compromised or could be, how does that change how you design these systems? It's not an easy question to answer, but I think it's an important one to put out there. And that's one of the reasons why, when I talked a little bit about CCE being one portion of the lab's work, another huge portion is focused on some of these other problems, one of which is supply chain security. So understanding what you have in your systems, things like software bill of materials, hardware bill of materials, peeling back the layers, and understanding how these components work together, it's a core part of how you understand adversaries target these systems. Supply chain security is scary in a number of ways, one of which is these are high value targets because, as we've seen from recent events, if you're able to compromise at some of these lower levels of the supply chain, the number of targets you can compromise is quite significant. So there's a lot of attractiveness there for a cyber adversary who's trying to maximize their returns with limited or small amounts of investment.
The other thing that I read towards the, if I recall, most of the way through the main part of the book, before we got into the appendices, was training, a focus on training, because the methodology, it seems like it's very thorough, and you're not going to be able to be that thorough, I think, by just reading the book. Can you talk about how do you become proficient in this methodology?
Yes, there are a couple of different options if you're interested in learning more. One of which is this training that is geared toward organizations that are seeking to partner directly with INL for an INL-led engagement. A lot of times, that being said, there's limitations on how many of those INL can do in a year or 5 years. We're quickly trying to ramp up the number of organizations and individuals that are capable of walking an organization through this process. But in the meantime, there's also been a lot of effort put towards training called Accelerate, which is designed to give individuals the tools necessary to return to their home orgs and conduct these kinds of engagements without an INL-led overseer.
So this is great, Sarah. Are there any other topics you want to hit before we wrap up here?
Just one. I think when you read a book or you hear about CCE, it sounds like a really concrete process with perhaps not a lot of flexibility to be applied to your own specific case. We talked a little bit about, what if my business model is primarily on the IT space, or what if I don't have those big physical expensive processes that were described earlier? There's criteria, they're called severity criteria, that you'll see in the first phase. They're designed to be flexible. We actually ask the organizations themselves to define what is most important to them before they start talking about worst case or thinking about what worst case scenarios would mean. It's there that I think there's actually a ton of additional value. And so I just wanted to highlight, if this sounds like maybe you're not a good fit for whatever reason, maybe you think that you've been in the industry a long time and you're not really sure where you're going, what you would learn from this. Or if you're new in the industry and you think that sounds really complicated, I'm not sure I could do this. That is a golden piece that can be used to start so many conversations inside your organization. Because I think security at its heart is protecting what's most important to you and your organization. And those are the conversation starters in that equation, in the severity criteria.
So, Sarah, thank you so much for joining us. This has been, tremendous. Before we sign off, is there a thought that you'd like to leave with our listeners?
Only this. If you're interested in learning more, you can go to inl.gov/CCE, because I think this is going to be a longer conversation, and we'd love to have you in the debate.
Andrew, something to take us out with?
Yeah, just let me say a few words about the book. The book is finally available on Amazon. I bought the Kindle version. I downloaded it. I read through it. It is a little shorter than I expected. I mean, this book has been anticipated for 2 years. It's a little shorter than I expected. It's a little more readable than I expected. I expected it to be very dense, very engineering focused, and it was actually easier to get through than I expected. The book, for people asking where does the book fit in the ecosystem, it is going to be seen, I predict, as authoritative. INL has done a lot of very sensitive risk assessments. The people that contributed the concepts to the writing that Sarah and Andrew did, these people are experts, and so we should expect that experts from all over the many industries are going to be referring to this book for a very long time. So I would encourage anyone who is active in the industrial security space to pick up a copy and to get through it. It's not as hard as I expected to get through it.
Okay. Thanks to Sarah Freeman for speaking with you, Andrew, and thank you, Andrew, for speaking with me.
Always a pleasure. Thank you, Nate.
This has been the Industrial Security Podcast from Waterfall. Thanks to everyone out there listening.